Broadcast is now starting. All attendees are in listen-only mode.
Okay, so good morning and welcome to this next in a series of retail webinars from Amazon Web Services. Today's session is called Using Data to Delight and Retain Customers with Machine Learning. So my name is Dr. Andrew Kane. I'm the Solutions Architect working for AWS, and I'll be joined by Praneet and Chris from Peak, who will be doing some of the slides later on in this session. Before I start, I'd just like to say that you can ask questions anytime you like via the question panel in the GoToWebinar app. Otherwise, we'll try and answer some at the end as well. These slides will be made available to you shortly afterwards on SlideShare, and you can also download the PDF now via the panel as well, whilst we're live. So the agenda, the thing I'm going to talk through today is firstly briefly touch on what is a single customer view and why this is actually important to this area. We're going to talk about how machine learning can actually help your customer experience, try and talk about what it can actually do for you. We'll talk about how AWS can help you build a recommendation engine upon user reviews. Then I'll pass it over to Peak, where they can talk about their AI ML platform and the functionality that it will deliver to their customers. Then we'll go back to a quick wrap up and a final Q&A before closing the session. So first, what is a single customer view and why is this important? So we actually talked about this in quite a lot of detail yesterday in one of our big data webinars, but we'll summarize it here quickly for those of you who actually missed it. So what's the problem with actually having a single customer view? Because every retailer has one of these, obviously. And the way you know this is because if you ask your senior management team, they know it's true. They've paid for a single version of truth or a single customer view. They know it's there. Unfortunately, many retailers also have many different single customer views, many single versions of the truth. And the tech teams basically pass back the question to the management team, which one do you actually want? Because we've got several. Now, occasionally, some forward-thinking individual builds a project to actually aggregate all of these into a new single customer view. But unless that company actually changes their internal processes, it becomes just yet another single customer view, and the cycle repeats. So why do retailers not actually have one? Now, there are many reasons for this, unfortunately. They're very malicious, which is good to hear. They're generally by accident, and every now and then it's actually done consciously. So one of the main reasons is you actually have a mixture of legacy and modern systems. These are not necessarily in the cloud. These may be sitting on legacy hardware or mainframe hardware, developed at different times with different data stores designed for different purposes. So these legacy systems, you're unlikely to find one that can actually deliver all the reporting needs, all the single view of the customer that you actually need. So there's so many of these actually spread about your estate that you end up having multiple views. Now, applications are often developed independently, often in different locations, different buildings, different cities, or even different countries. And unfortunately, they're also done often with no overall plan or strategy. If you ask 3 global development teams to build you 3 apps, they will chiefly build you 3 apps. And it's not very often will they actually get together and discuss how those apps actually integrate properly, how they actually add to the customer experience. They'll do their own thing because they're developing these things independently. And even if they're in the same office, I found that some of the customer teams don't actually talk to each other. Even when they're sat at the next desk, they would rather email than just tap someone on the shoulder to ask a question. So really, it often feels like these teams are in different planets, never mind different offices. And finally, bugbear for all development teams is there's a pressure to deliver quickly in almost every software project I've ever seen or ever worked on. And therefore, we often see a number of ad hoc or tactical solutions that the dev team and the project management team absolutely promise will be fixed in the next iteration. And more often than not, these things aren't. They're just left there and they become yet another single customer view. So what sort of disparate systems do you actually have? There's going to be many types of systems in your environment, all of which could end up being their own independent system of record. Now, the obvious one for retailers, this is going to be your large, heavyweight e-commerce platform. This is basically the main system of record you have internally. But it may not suit all the reporting needs. It will happily handle things like transactions, what the customer has bought, where things got delivered, overall values and things like that. But it might not hold a lot more information that you actually need to do this proper big data analysis going forward. You also have a number of line of business websites. You may well have your own sort of clothing brand. You may well have grocery brand. You may well have general merchandising brands. Each of these websites will have independent user profiles. They'll often have independent data stores, and they'll often hold different aspects of information about the very same customer. Thirdly, a lot of historical data will often go into a big data warehouse to do this sort of large-scale data analysis that data scientists love. So it'll hold all your legacy, but it could also potentially hold all of that clickstream data you've been collecting for many years and don't know what to do with. So again, this holds another sort of big mine of data you can actually go after to help your machine learning systems going forward. And finally, often forgotten about, is the actual point of sale systems themselves. These actually generate information within the store, which is not necessarily e-com related. It may be the payment methods that are being used, the loyalty information or loyalty cards that customers are using, what special offers were actually triggered as part of that customer visit, what marketing promotions have actually had a positive effect, and things like that. So this kind of outlines the actual problem of customers, or retailers don't tend to have that single view, and without it, they actually only struggle to pull the information together to actually give a customer a good user experience. So what can machine learning do for your customer's experience? And first thing they can actually do is they can help customers actually find what they need, even if they don't know what they want. So one of these main areas is in image recognition. It's one of the most rapidly improving areas of AI, and the ability to look at pictures and work out what they actually are powers the Amazon shopping app and many other retail apps. The customer sees something that they actually just like, they take a picture, and the app's image recognition software will find something very similar from the inventory and order it. So the user scans something that they actually like. In this case, it was the first thing I found on my desk when I went to build this presentation. Random cleaner that everyone probably has around their home or in their offices. And sometimes it might just be a barcode or just a packaging that you have available to you, but most of these apps can actually cope with that different level of detail. So you take a picture of it, and the Amazon shopping app will find it in the inventory or find multiple items that are quite like it in the inventory. And then with one click, you add it to the basket, and then the next day, or possibly even the same day, it will arrive at your home. Now, if you have one of these Echo devices that have a camera built into it, you could actually ask it to buy this just by showing it up to the camera. So using AI behind the scenes helps customers find what they need, find it quickly, and just being able to say things like, just buy this, without having to worry about how to navigate through an application, navigate the inventory, do searches and things like that. AI ML just works out, you just want one of those, I'll buy that for you. And that's, the job is done. But it can also help you organize and understand your data. Now, this is really our general purpose data pipeline. We talked about this a lot yesterday in the Big Data webinar. In this, we talk about ingesting data from multiple sources. We actually store it in multiple different ways, and then we repeatedly process and analyze it, and finally consume it in some other system, or perhaps just simply visualize it. But the problem with this is, you may have too much data. Do you think you have too much data, or do you not have enough data? Data is the lifeblood of all your marketing decisions, but as that data volume grows over time, which it will, analyzing it becomes tougher and tougher. Now, AI and machine learning can deal with vast quantities of data. They can sort it, analyze it, and extract patterns from it far more quickly and more efficiently than us pure humans can. And more importantly, it can do it in real time. So this live data could be coming in from multiple sources. It could just be live chats from your online support teams, or it could be getting streamed in from the myriad of social media platforms that we have these days. So using various different AI tooling, you should be able to extract text representations of all these channels and do something with the information in a meaningful way. But before you can react to anything, you need that text in a language you can actually understand. So first, let's translate that Spanish tweet into English and start from there. Now, AI can then do things like sentiment analysis on that particular text, and it can come back and tell you useful information such as, was that customer being positive, or whether being negative? Was it a glowing review? Was it just a general grumble? And hopefully the sentiment can actually come back with some interesting metrics to say, this tweet feels like the customer is very unhappy. And just by having information, it means you can then do something with it. But what are they unhappy particularly about? What you can also do from these text systems is extract entities from it, such as places, dates, and organization names. So if you see a tweet along the lines of, there was an excellent AWS meetup last week in Cambridge, then you can extract information such as last week to infer a date, Cambridge to get a place, and from that, your marketing teams can actually go and correlate what that tweet event actually referred to. But without this information, you'd have to get a lot of human intervention to read these tweets and actually try and work out what's going on. What are they actually talking about? Now, you can also extract common noun-based phrases. This is really important for other sort of aspects of natural language processing to actually understand what's being talked about. It might not be very useful in the immediate short term to react to a tweet, but it's very useful going forward, because once you have a large number of these phrases, you can perform things like topic modeling using AI on large sets of data. And you can categorize all your incoming streams into different categories, into different topic groups to allow for easier searching and easier analysis later. So basically, AI and AML can look at all of these channels and give feedback on what your customers are actually currently thinking, as in thinking right now, in absolute real time. So this intelligence is basically gained from data, and it will give you an accurate picture of what your customers think. Without AI and ML in place, you simply will either can't get that data in the first place, or you can't actually respond to it fast enough to actually do something meaningful about it. You wouldn't be able to resolve customer issues as they happen, and you may actually have to wait until large numbers of complaints are announced unexpectedly on the evening news, and that's not a situation anyone wants to be in. AI ML can help you spot trends within minutes, and you can react to them before these things actually break out to become a bigger problem. One thing also lets you do is never run out of stock, or more to the point, it tries to stop you from overstocking, which is just as important. So not having what people want is not really just a supply chain issue, it's definitely a customer experience issue, and it can lead to shoppers just going elsewhere. If I go to a retail store because I've seen some advertise it on the television or the radio, or I'm looking for a particular special offer that's just been announced, and I go to that store just for that offer and it's not there, that's a very negative experience. Because that basically makes you think that the retailer isn't really caring much about the customers, and they just aren't organised enough or planned properly enough for this particular marketing event. But AI has an ability to consume and analyse vast amounts of data so that it can actually predict customer buying behaviour by using lots of different information sources, such as weather forecasts. This massively impacts things like ice cream sales, and whether city bicycle hire are going to be more inundated one day rather than the next day. Just by knowing what the weather is, you get more information and you can make better decisions. Any public holidays. A public holiday will affect footfall traffic in stores one way or another, whether it's positive or negative. It doesn't really matter as far as the model is concerned. What's more important, that it has the right level of stock to actually cope with that particular day. Events can also be quite a big thing. There could be national events such as the Football World Cup over the summertime, which went on for quite a long time this time, so retailers were very happy at that. But it could be a very localized event that just affects, say, 1 or 2 stores in just 1 or 2 cities. And by having that information, you could also make sure stock to particular locations is targeted for what's happening in that area. Marketing promotions. These are the biggest impact on stock. If you're on a large promotion, and then stock that was part of that promotion will disappear rather fast. It could be the effect of also television presenters talking about things, especially in cooking programs, which happens quite a lot. And you suddenly find this new ingredient has disappeared from all the shelves across the UK in like the next day. So by being aware of these promotions, by being aware of these events, you can actually make better judgments and better predictions on the stocks you actually need. But it's not all about what's happening now. History is also quite important. So we can also utilize other historical information, such as what was the price history of this particular product or this particular product line, and what was the actual sales history of that product line over time. And with all this information put together, all this historical data, you can basically perform very large-scale time series analysis on all that data sets and give you excellent quality forecasts based on data volumes that a human analyst simply can't grasp. So this analysis allows you to make sure you have the right inventory to match demand on a particular day in any part of the country. Now, 24/7 customer service is something every retailer would love to have, or in fact, pretty much every organisation would like to have. But you need a lot of people to actually run a 24-hour operation. Now, for many organisations, that's just not feasible. But what's coming up more and more these days are things like chatbots to partially fulfil this, this function. Because chatbots don't need offices, they don't need food, and they don't need sleep. So while your humans are actually in bed resting, these chatbots can actually keep your call centres open. They can take calls all day long from any part of the globe. Now for this, we say Lex, the Amazon Lex service is a great place to start because it lets you easily build a text or voice-based chatbot. And from that, you can link in other services such as Amazon Translate, and you can suddenly give yourselves a multilingual online support staff that would ordinarily cost you thousands and thousands of pounds to run on a weekly basis. But you can now do this from the comfort of your mobile phone using a bunch of our services. Something else that is useful is Amazon Connect. Gives you a complete contact center as a service in the cloud, providing call flows and call routing that you'd expect from existing telephony systems. We've talked about this at a few events in the past, and it lets you do things like reorder flights. You can do things like reschedule meetings, change appointments. Basically, you can handle the mundane things that you'd almost be wasting a talented human support engineer to actually deal with it, but in person. And you can use the chatbot system such as Connect to actually handle that for them. The one big benefit of this, of course, is the way Connect is actually built to work. You can actually drop out to a human operator at any time you like, whether it's at a point in error in the flow. So in the case of booking a flight, if there's no flights available on the next day, you drop to an operator and let them deal with it. It could be the flow design, it could be just by user request. So lots of ways to get back to the humans. You actually need a bit more interaction or a bit more intelligence behind the scenes. But for most of the mundane, we think that things like Connect and Lex can handle an awful lot of your customer service issues. And Sumerian, I hope some of you saw the Sumerian presentation yesterday. It's one of our newer services. This takes us all one step further and actually gives you full augmented virtual reality concierge, which again, you can link back to Lex for a highly enriched visual chatbot. So rather than just talking to a blank screen or talking to a microphone, you can actually have something on screen that looks, acts, and responds like a human in terms of motion, eye contact, following you around the room as you move, as you can see on the camera, and things like that. So a mixture of all these things, we think you can actually get 24/7 customer service just using our native apps, our native services out of the box with minimal development time. Also, what AI is good at doing is concentrating on what we humans are pretty bad at. So looking at tasks such as customer churn risk analysis, time series forecasting, anomaly detection, they're all big things that we would like our systems to do in retail. But basically, as humans, we simply cannot do this. We do not have the attention to detail and the ability to repeat the same mundane tasks 10,000 times. We just look at that pattern on screen and see if you can actually find the pattern that's behind it. Good luck. You would need an awful lot of machine learning power to actually work out what's going on in there. And really, if you see that as a human being, it's just really hard to pick out all those deep patterns. The identification is just too hard. So machines are perfect for this. So they'll need to look over, if you need to look over the last 5 years of customer mobile phone usage to predict customer churn risk, no problem. Do you want to do time series forecasting for stock control? That's actually quite easy. General anomaly or just plain old fraud detection? Well, it's not quite a piece of cake, but it can easily be done with a few good ML techniques that are well known in the field. So all of these actually help the customer experience, but they just might not know it. Without AI and ML, this would either be too hard to do in the first place, or it would be wildly wrong and actually detract from the customer experience. We've been told by some retailers, of course, that having no model at all in terms of forward stock planning, it can actually be better than having a bad model that just gives you the wrong results or just gives you a bad experience with the customer. So what we're trying to do now is we're trying to build a recommendation engine based upon user reviews. We'll probably not quite build it because we only have 10 or 15 minutes left, but we'll walk through the steps to actually do it and refer you back to one of our blog posts that goes through it in massive detail. So I'll just talk about what we're actually trying to achieve here and how we can actually help you go about doing that solution. So recommendation engine basics. A lot of these simple systems out there now are simply based on people who bought that would like to buy this. And they're often quite poor because they'll literally say, someone bought this in the past, might be nothing to do with you, in relation to your shopping habits, your experiences, anything like any of your likes and dislikes. They just happen to buy one, so please buy another one. So I see this on websites all the time, and I often see adverts for things that I've already bought. I'm not going to buy them again. Just because I bought something out of the ordinary a few years ago for my 4-year-old daughter doesn't mean I should be prompted to buy things like huge green soft toy dragons for the next 5 years, which still happens. This isn't useful to me, it might be to her, but there's no relation to my shopping history, my preferences, or why I'm actually on this particular website to buy something. And really, as far as I'm concerned, I think it's really just acting as clickbait to try and get me to go buy things I don't really want to do. But if I see targeted advertising, if I see advertising and recommendations that actually match my interests, this is much better. Because customers can see through this really easily. You'll find it just doesn't really work if there's no real intelligence behind your recommendations. Now, on the Amazon Retail website, we actually have the frequently bought together section, as well as the customers who bought this item also bought section, but they're far from simplistic. So I'd like to introduce you to Shop Counter Guy. And this is really what you're trying to achieve. Basically, if you ask the Shop Counter Guy for a product, he'll show it to you. But also, he'll try and show you related items that you might be interested in. He's an expert in both cross and upselling. And there's 2 main techniques that he'll use for this. The first one is called collaborative filtering. So this relies on people actually putting in reviews. So it relies on the dislikes of me, the dislikes of you, and the likes of other people. So the idea is it can look at all these likes for people who have bought similar things, and if it can actually work out that I've bought book A and C, you've bought book A, B, and C, I might like book B. So it will use those sort of interests to try and work out, well, other people who buy the stuff that you do also have bought this. And so the good way of actually saying that we've got some good data, good logic behind the scenes that says you should like book B, so please give it a try, recommend it. And if I see that, I might see the reasoning behind the recommendation and think, oh, that's a good idea, I'll buy it. Or I think, actually, I'm not interested, but good call, nice idea. The other option is content-based filtering. This relies on the properties of the item that you actually like. So we'll try and find things that you like based on what you've already bought in the past. So a good example is books by another author. So if I like, say, books by Anne Cleves on the Shetland Islands Detective Mysteries, which I've always liked, they'll recommend me the new books in that series as they get released. But they might also recommend books to me on Viking history or Viking archaeology in the Northern Scottish Isles, because again, the books contain many of those themes. So the content-based filtering can actually come up with some really good recommendations as well. But unfortunately, the big problem with this area is if you have a content-based recommendation system, do preferences in one area, such as which news stories do I read, does it imply preferences in other areas, such as music? Probably not. So hence this is why hybrid approaches actually exist, and this is where AI and ML actually come in. So let's do a movie recommendation system using Factorization Machines on Amazon SageMaker. We published a blog on this just a few weeks back in June, and it was called Cunningly Building a Movie Recommender with Factorization Machines on Amazon SageMaker. Well, the link is actually later on in this deck, so you'll see that when you get the materials after the session. But this is what we're trying to actually do. Here's a review matrix of, excuse me, 4 movies from 5 different users. And I just telling you, marks out of 5, what they actually thought of it. Now note there are quite a lot of gaps. And these are the gaps we actually want to fill. We want to see, will user 5 like the sci-fi film? And you can look at this matrix and think, well, users 1 and 2 liked it, but they hated the drama films. Users 4 and 5 loved the drama films. And user 3, but users 3 and 4 hated sci-fi. So you can look at this and think, actually, I can make a good guess that user 5 might be a 1 or a 2 for the sci-fi film. And that'd be a fair guess. But when you have many, many thousands of movies and many hundreds of users actually doing movie reviews, it becomes really hard to just look at this as one picture and guess. So, yeah, so in the database we're actually going to use as part of the blog post, 93.5% of the matrix was blank. So there's an awful lot of blank holes to actually fill in, because if you have 1,000+ movies and several hundred users, they only review a few each. So the sparsity of that actual matrix is huge. Now, the reason behind we do things like matrix factorization, which we'll talk about on the next slide, is there will be some latent feature that determines a user's rating. Perhaps they're big Matt Damon fans, and they would rate both The Martian and, say, the Adjustment Bureau films quite highly, even though plot-wise they're actually quite different, and genre-wise are quite different. He's an actual hidden facet, and the reason why they give it quite a high rating. So their preference towards a particular actor is going to be based upon this hidden feature of the reviews, and because it's not explicitly stated in the matrix. So this is what you're trying to actually achieve. Why do people like this film? What's the reasons behind it? What are the hidden features we're trying to that force my decisions to give a rating movie a 1 or a 5? So I have to apologize big time. There's some maths coming up next. There's not much, it's quite small, and I promise not to do it again. So here we are. So what we need to do is solve this equation. We have matrix R, which is our movies and users review numbers that you had on the previous slide. And we have to work out 2 different vectors called P and Q. So this is the one that's sparsely populated, as we talked about. So there's going to be a lot of gaps in here, not even zeros, they're just literally gaps that we have to find. So what we also have, we've decided that we have K hidden features. In this case, we're just looking for favorite actor. So I'm going to say K is 1 in this case. So we have 2 other matrices here. We have the users matrix, which is the number of users by the number of hidden features. And we have another matrix, which is the number of movies by the number of hidden features. Now, just by basics of maths, there absolutely must be 2 matrices P and Q, such that if you multiply them together, you will get R. There absolutely has to be a solution. The trick is, how do you actually get to that solution? How do we get to that matrix? So what factorization machines do is they use gradient descent algorithms, which are the fundamentals of the old supervised learning mechanisms in neural networks. And they try to minimize the error between the actual ratings that we know about and the ones that come about as a result of multiplying P and Q together. And we keep doing this, we go through the same loop over and over again until that error converges on what we think is a minimum. Now, we don't try and overfit, we don't try and say, let's get the ones you know about estimated to 100% accuracy, because what that generally does, it means the ones you haven't seen before are quite poor. So we introduce extra parameters as part of the factorization machines to say, well, let's try and keep it a bit more generic, let's not make it overly perfect and things like that. So when we do this, this is what we actually get. So if you're in this through the actual blog that we have online, you'll get something along these lines. So this shows that user 5's interest in sci-fi films is just over 1. Now, you know from looking at that matrix yourself, that's about right. That's what I'd expect. But there's other ones that's filled in, such as user 2 that it hasn't seen before. And it's giving its best guess just looking at all these numbers, looking at all these movies, all these users, and saying, actually, from what I see, using factorization machines as a method, these are the numbers we should be filling in. And you'll also see that the ones that we knew about, such as most of the sci-fi ratings, it's approximately got them all right. Not quite, but they're pretty close. And this is what we actually want to see, because it means we have, hopefully have, a reasonably generic algorithm that will actually give you a good set of reviews. Now, if you take this result and put it on your website, you would find it's actually quite good. Customers will find it's not that bad. It's giving you recommendations that seem to be in line with what we know about those individual users. So, it's not as simple as that. Now, the review list you get from your website is unlikely to be a matrix, unfortunately. It's going to be a list. It's going to say, user 1 gave the sci-fi film a 5, user 2 gave the sci-fi film a 4. And you're going to have a big list like this. So it's not the matrix we need. So we have to do something about it. And in the actual data set that's used in the blog, there's about 90,000 different reviews. And that has 943 different users and 1,600 plus different movie names. So what we actually do is we create a hot encode dataset, or one hot encode dataset. So we change this. We create a matrix where we have a column for every user. We have a column for every movie. And in that line, every single value is blank, except for the user that it's talking about. So this first line that has user1 with a value in, and it has movie1 with a value in, just to indicate this row is about that movie, that user. And you repeat this for every single line that you have. And this will give you a matrix that's 90,000 samples deep and 2,500 columns wide. But once you actually do this, the matrix itself is now 99.92% sparse and empty, which is absolutely awesome because that's just what the factorization machines actually need. Now you notice the actual rating number itself isn't in this matrix because the way the actual algorithms implement is in the end, they've taken the actual rating off to one side and deal with that as a second matrix which you input to the factorization machines. This is the way they split up the data because it just makes it work faster, which is what we actually want to do. But I won't build it because I'll leave that exercise to you because it will take you a couple of hours from a standing start to get this built and running. So rather, I'll quickly go through the steps that the blog takes you through. And there's the link at the bottom of the screen. And show you how simple this actually is once you've gotten those data sets into a sparse enough state to be useful. Step one, according to the blog, is you open your notebook instance in SageMaker. You activate the conduct environment and import your training data from S3. That's it for step one. Step two is train. You build an estimator model, which is built into SageMaker. You tune 3 parameters, which the blog talks through in quite much detail to why you have to change them. And then it calls the fit function, which is basically the training function. And then you sit back, you watch it go through something like 50 iterations, 50 cycles. And at that point, you'll see an accuracy of something like 72%, which is not actually half bad. That means if this site showed me 4 movie recommendations, it's probably got 3 of them right, which is much, much better than just saying someone who watched movie X also watched movie Y. It would be much, much more accurate. And even then, you could look at the hyperparameters later and decide, oh, let's go tune them some more. Let's tune 4, 5, 6 of them. Let's change the values. Let's change the thresholds. And once you play with it a few times and spend a day or two with it, you'll get that test accuracy much higher. But we would recommend don't try and go much higher than sort of 80, 85% because you'll start to overfit the data again. Let's try and keep it down at in the levels of 70 to 80, and that's actually quite a good system for customers. But once you've done that, it's a one-step method to say deploy. And that will now become a SageMaker endpoint that you can just pass your JSON data to say, please recommend this person some movies, please. And that's it. It's actually that easy. So I'd now like to pass you over to Praneet and Chris from Peak, and they will talk to you about what they can do for their customers in this particular area.
Thank you, Andrew. And hello, everyone. I'm Praneet Chandra. I'm head of product at Peak. And today we'll talk about Food Asylum. It's a multi-brand retailer here in UK and how we powered the whole e-commerce through AI and machine learning for them. So let me give you a bit background around Peak. Peak is artificial intelligence services for business, and it's powered by our own artificial intelligence system. This artificial intelligence system allows our data scientists as well as customers' data scientists to rapidly build and deploy machine learning solution. And we are a fully managed service, so we are always invested in customers' growth and revenues, basically, as well as we are AWS Advanced Machine Learning Competency Partner. So let's dig into what this AI system does. So as Andrew mentioned a few slides before, that you get a lot of different data from social, from web, from your CRM, from your POS systems. And this all data needs to flow at a single place where you can actually do some machine learning on top of it. So Peak AI system actually gets all of that data from several different sources, be it your data warehouse or it could be your POS systems through this data ingestion or web uh, connectors. And then all of that data flows through our inbuilt GDPR algorithm. This GDPR algorithm actually helps us screen the PII or personal identifiable information data, and we can then selectively choose not to get that data into our system. And once that data comes into our system, our data scientists come to our product or SaaS solution, basically unify all of that data set, and then apply the predictive modeling techniques. That could be a regular supervised learning or a normal statistical method. And then they deploy train and deploy a model on top of it. And this model then can go back and integrate with the other systems. It could integrate back on the website or e-commerce shop through an API, or basically it can even produce a list of email addresses and the products that you should send it out to customers. So let me take you a bit on the Amazon view, how it actually looks like. So on the left side, you can see all the different sources coming in. And what we do is basically we build out a client data layer, uh, basically a whole data lake for you that is actually fit for machine learning. And on this data lake, we run some of our predefined machine learning transformation that helps doing the feature engineering and other things. And it helps us to clean and modify the data. And then after that, we use AWS SageMaker in order to build and deploy models, basically. And then these models are hooked to an API connection or can be hooked on a recurring orchestration basis that can actually produce results for you. Yeah. Moving on. So what we did for Food Asylum. So Food Asylum is basically a multi brand retailer, and what we enable them is basically hyper personalization through AI for their e-commerce system. And the impact that it went was basically 31% uplift in the revenue on the per email send and 74% reduction in basically acquiring customers. So we actually help them build out what is your ideal customer profile that you should look around for, and we gave them a smart segment that you should target with. And it also helped them reducing the stock, since we could actually predict what is the demand in the market. So I will pass on at this point mic to Chris, and Chris was our lead on uh, Food Asylum project, and he would take you through what we actually did for them.
Thank you, Praneet. So our vision for Food Asylum is to help increase purchase frequency and average order value through the use of hyper-personalization in marketing communications. We wanted to address three fundamental marketing questions. What does the customer want to purchase? When are they going to purchase? And how should Food Asylum market to them? In order to achieve this, we built a single customer view of Food Asylum's customers, unifying data from multiple data sources, including transactional, demographic, online behavior, and marketing data. We fed this data through Peak's automated transformation algorithms that augments the data and joins it to Peak's library of proprietary datasets. We use the transformed data to build models to predict certain customer behaviors. This includes using gradient boosted trees to predict the time until next purchase, as well as marketing channel and campaign preferences and estimated lifetime value. Survival analysis was used to predict churn, and additionally, we performed supervised clustering in order to track the growth and value of specific customer groups. These models are used in conjunction with each other to decide the most appropriate campaign template, content, and if required, incentive to send to a customer at any given time. This is used to power the recommendation that pulls specific products from Food Asylum's product bank that fulfills the requirements of the model. We use a mixture of business logic and then collaborative content-based and demographic-based filtering algorithms and deep learning techniques to build a model of the customer's preferences. The recommendation engine is hosted on AWS SageMaker, which allows us to support the deployment of hyper-personalized marketing campaigns and online customer experiences. For example, depending on where a customer is on a given predicted purchase cycle, the recommendation engine will output products that meet the customer's preferences, but also helps increase Food Asylum's metric. A customer near the start of the buying cycle may be targeted with potential upsell and cross-sell products, whereas those past their peak in the buying cycle are showing more promotional content to minimize churn. Each customer's buying cycle is different, and therefore knowing when it is most appropriate to send premium or promotional content is essential to drive repeat custom while maximizing profits. Okay, I'm just going to pass you back to Praneet now.
Thank you, Chris. And I will pass back the presentation to Dr. Andrew, and he will take us through it again.
Okay, so into the last few minutes now, so I'll quickly wrap this up, and then hopefully we can go into some Q&A. So across this whole thing, we think customer experience is actually key. This should be at the forefront of all of your business concerns. If there's something that you're doing that actually affects the customer experience, then it should only ever benefit that customer experience and not detract from it. Adding in additional systems, no matter how cool they might actually be or how flashy it might make the website actually look, if they just help your own business at the expense of the customer experience, that's not a good thing. You must go out of your way not to try and detract from the users and how they actually go through your websites, how they purchase things, and things like that. It's an absolute key thing you must do. So they must enhance the ability of the users to provide customized recommendations through insights into their behaviors, into their preferences, into their various activities. It must not just be there for you to troll for large quantities of customer data. The customers are going to be wary of AI ML. It's quite obvious in the press for the last couple of years that a lot of the general public just don't like the idea of it because they don't really understand what it does, what it actually delivers, what benefits you can get. But if they can actually see tangible improvements to their experience on your websites, they'll begin to accept these things. They'll start to talk more to the chatbots and such like. They'll start trusting with the actual voice data because they can see tangible benefits to them in actually using your site if they give you that information. But it's quite an important but. It takes time to learn. Do not expect an overnight sea change in the sort of results on your site. Businesses hoping to win consumers over the long term should be mindful that any system that offers any capabilities, whether this is standard ML modeling or whether it's chatbots or anything like that, the accuracy of those systems will improve over time. Now, in your first deployment, you're going to get data aggregated from all the information sources you can find and pull together. And the initial deployment of those might actually be quite good. You might get much better results than you initially thought you would actually do. But as you start collecting more data, as you start training those models again and again, you'll find the models get more and more accurate. It will just get better and better. The customer experience will get better and better. So this can take weeks or months of these systems being live before you start getting a bigger sea change effect in what's going on. But you have to say, remember, you're not alone. If this kind of work actually feels quite daunting, because AI ML is actually quite a difficult subject, but despite our tooling out there, you might think it's a bit too much for your team to take on. There's many different AWS partners actually out there, such as Peak, who can help actually do this for you. And whether that's helping build systems for you on site with you or help delivering systems as a service, such as what Peak do, you don't actually have to build them all ourselves. So don't be worried, don't be too scared. Go out and do it, follow our blog posts, but if you think you have to leverage our partners, then go and do that and get a jump start in using AI ML in this area as a whole. So that's it from me in terms of presentations. So I'd like to pass it across to any questions that we happen to have coming in through the system. And right now I can't see any. Okay, a bit of background. I was talking to an actual national bank last night on topic of machine learning, and the question they actually asked quite seriously was, we like the presentations, we like what we see, we like the ideas of doing, say, things like fraud detection, but where do we start? What's the first thing we can actually do to try something out? We've sold the idea of machine learning to our board, but what can we actually do that will deliver something in the short term? We know it will take us like months and months to learn the topic, it will take us months to get partners in and get them to build something, and it has to work. But what can we show the board like next week? And this is why we push our blogs quite a lot. We have a lot of sample different solutions. The one I mentioned about the movie recommendation system, that could be applied to anything, to any particular product set that you have, not just movies. So by going into that blog and running through it, you'll actually get some very, very quick first-hand experience of building one of these systems and seeing how it could work. We had one at the start of the year, which is to do with extracting tweets, pushing them through sentiment analysis, putting them through Amazon Translate, and actually dashboarding what it saw in terms of positive, negative sentiment, what it saw in terms of geolocation of those tweets, using the QuickSight dashboarding we have, that BI tooling. And again, these can be done in like half a day to a day from a standing start without knowing anything about those technologies. So we try and use these blogs to give people that first initial taste of, if you just go to the blog, if you just do this one thing, suddenly you'll have a level of understanding of that topic that's so much more than you probably have now. And you can actually say, well, we actually can translate tweets. We actually can do things that recommend product sets based on customer reviews. And we've now seen it work. How can we actually apply that to our business? And it might sort of jumpstart a few steps of your processes to try and convince your board members to actually do this. So we recommend you go and do these things first and get that very, very quick win that you can demonstrate back to the business and show it back. which will hopefully involve very, very minimal effort from your side. In fact, you spend more time probably writing up what you found and writing up the conclusions of what you've done than you'll spend actually running those blogs. Okay, so a question on advice for new tools of machine learning at the core, such as natural language processing, computer vision, and such like. Any new customer journeys for bricks and mortar stores? Yes, there's quite a few. There is a huge trade show each year in New York called NRF, which we were at the last this year in January, going again next year. And for that, we had a few different rolling demonstrations to the audiences, just on our basic core services. So good ones of that are things like recognition is always a really good one to try and recognize people as they come into the store. Now, you can do that to recognize things like VIPs that are coming in, and you can do it to recognize individuals, sort of platinum members of your VIP club or your loyalty card system. But what it's also good for is literally counting faces and looking at the sentiment. One POC we did at one point where it was just literally scanning people's faces as it comes into the store, looking at the sentiment, and then doing the same thing as they left, and trying to see was there any sort of correlation between their happiness levels between coming into the shop or going out again. We also have the ideas of having things like chatbot or now Sumerian-based host at the end of each aisle, where you can ask it such things as, where are the cornflakes? Where can I find the baked beans? What's the best offer on lemonade? And have the chatbot go through, interrogate the inventory, and come back and say, it's not aisle 6. Or in the case of Sumerian, point you towards aisle 6 on a virtual screen on the map. Now, these things are actually out-of-the-box services. You just literally have to plug them all together, wire up them with some individual bits of code, but they are just there, and you can build all these solutions together with absolutely minimum effort. But to get a fully functioning chatbot together to ask, where can I find a particular item in inventory? I think myself and another essay, we spent half a day on it, and we almost got it working to a level to show a customer literally in half a day. So these things you can pick up quite quickly. And again, with NLP, if you're actually picking up the speech through Lex, as well as trying to work out what to do with it as part of the Lex conversation, you could pass that straight to things like Amazon Comprehend and say, now, are they feeling happy? Are they feeling, does it sound upset? Are they asking about an item in a sort of nasty way, or asking about stock levels because they sound annoyed it was out of stock? You can link this all together and do things like that. It works very well. So got time for another question. What happens if there is irrelevant data for calculations? Recommendation engines, if they're still waiting for relevant data. Yeah, so the point of the factorization machines is it's designed to work where your matrix of recommendations is actually very sparse. So it's quite happy with it if you just draw the 202 matrix out on the screen. If that's like 90% sparse, it's actually quite fine with that as an idea. You just have to have something that overlaps. If you have 1,000 users reviewing 1,000 films and each user does one film, you're not going to get very far at all, unfortunately. So you actually have to make sure that you've got one person doing, say, half a dozen films, the next person doing 10. And once you get enough reviews built into the system, even if you're 90% sparse in that 2D matrix, the factorization machine approach can fill that up really well. And it can give you a pretty good example, a good approximation of what those reviews should be. How about mobile apps? Some of the things we've looked at doing inside retail stores, such as the end of aisle things, they actually require connectivity back to things like the Amazon recognition and the Lex endpoints. And they're hosted on the public internet, essentially, because they're public-facing services. So as far as your mobile app's concerned, it's just a push over your user's 3 or 4G connection or the Wi-Fi connection onto the public internet, and you can hit all of the endpoints for things like SageMaker, recognition, Lex, and everything else. They're just there. Now, of course, you could also use mobile applications and use things like AppSync to actually send data from your app to your infrastructure in AWS, and actually use that to call those endpoints privately if that's what you want to do. There's nothing stopping you doing that as well. But really, for mobile apps, there's nothing different. The endpoints are the same. They're in the same place. They're available to everyone, whether they're mobile, in-store. As long as you're on the network, they can get to the internet, or you have private VPN or direct connectivity back to us, then you can access all of our endpoints. So for mobile apps, there's no real problem actually doing this. The one thing we have seen with customers is when they try and do sort of full facial recognition applications, they'll scan in the picture using that camera on the phone, which can now be like 10 meg plus for the image, and then they have to send it up to recognition to do something with it. So again, for things like that, there's things you can do to minimize the data transmission on your side by quantizing that image down to 1,000 by 800 rather than the 10 megabit that you have, or megabytes that you have for the image, and just make it smaller, more manageable to send it up. I think that's probably the only thing for mobile data or mobile applications that's worth recommending. running out of time, so I'll pick one more. Would you recommend a solution for embeddable setup using visual recognition to ID patients? As long as the recognition system that you're going to use can deal with what it can actually see, then there's nothing wrong with doing that as a sort of one of the multi-factor authentication methods you can use. If it's using our recognition service, we can recognize faces. We can't recognize any other part of the body, so we can't do things like fingerprints. You might want to have some other methods to say, well, we've seen the face, we know this is particularly this is Sue or this is Bob in the hospital, but we can't tell anything else about them. We're 95% accurate it's this particular person. We would use that as one of the checks to say giving out medication as the orders and nurses go around in the evenings with the medication rounds. You would do that as just another check. You wouldn't rely on it or just on that to be 100% sure that this is Bob or Sue in the hospital bed. You'd make sure that's just one of the things that you can do. We could add it in as an extra check. There's nothing wrong with doing that at all, and it makes it a very, very additional secure system rather than just checking sort of the bracelets or barcodes. It's something else, and these things do work quite well. So, is there any left? How many data rows do you need to start a basic recommendation ML app? Probably a couple of thousand as a minimum. There's no real hard and fast rule. If you have a couple of hundred rows of data, you'll train something, but you'll be training on a very small sort of data set. There's not going to be that much for it to grab or latch onto in terms of modeling. So you might find it's learned completely irrelevant things because you've not got a big enough corpus of data to do something sensible. So once you get into the realms of thousands of rows of data, you start to have a big enough spread of data for the recognition or the AI engines to actually pick something out that makes more sense. So you can play around with the algorithms and play around with the tools with just a few hundred rows just to get a feel for things, but I think you've got to go to the thousands before you start doing anything sensible. As I say, the movie lens data set used in that blog post is 90,000 or so reviews. And the review is literally just user movie rating, that's it. But it needs a few tens of thousands of reviews to make that really, really impressive. It works quite well. But at the start with a few thousand, you'll start getting decent results from that. But as you build that up more and more, the training of those algorithms will take a bit longer each time, of course, as it gets bigger and bigger. But I think a few thousand is a good starting point for doing things. I think that covers everything that we've got. So I think we're out of time. So thank you very much for your time. I hope you enjoyed the session. I look forward to seeing you again in some of the other ones we've got coming up for the rest of the week. So enjoy the rest of your day. Thank you.